Hello everyone, welcome back to my channel. Today I am breaking down the something that is genuinely transformational for the Ethereum future, the Ethereum Interop Layer of EIL. So this is not a layer 2, not a bridge, not a wallet feature. It's a new communication layer that unifies all chain in the Ethereum ecosystem. If you have ever bridge assets, switch networks or left cross-chain UX pain, EIL is the design to solve the all of that. So today we discuss about EIL. Let's start with the why we need the EIL and what type of fragmentation problem Ethereum L2 ecosystem see that, and what problem Ethereum has multiple layer 2s but they don't behave like one ecosystem. So we break down here the each point of layer 2, what the problem. User constantly switch networks, bridge and RPCs. Wallets feel disconnected across L2s. Like wallet change RPCs, chain interfaces, and user switch network constantly. Apps on the L2 cannot interact directly. Apps deployed on L2 but cannot call another contract directly. The poor cross L2 UX reduces the adoptions. The UX is painful for the we have to go in for one chain to another chain. Every L2 acts like a separated island. Right now, Ethereum ecosystem is scaling, but the scaling into fragmentation instead of the unity. Here's the one diagram showing that is the Ethereum ecosystem. Here's the Ethereum layer 1 that connected via EIL with the different chains and other L2s also like Arbitrum, Optimism, Polygon. So they all connected with the EIL and with their Ethereum layer 1. So right now Ethereum ecosystem is scaling, but it's scaling into fragmentation instead of the unity. A dApp on Optimism can't directly talk to the contract on Scroll. Everything feels like a separated island. This fragmentation is like the biggest roadblocks of stopping Ethereum from feeling unified. Imagine having a 10 version of Gmail, each with the different login buttons and different inboxes, and that's like Ethereum today. So why interoperability matters? Interoperability isn't luxury. It's a backbone of the multi-chain future. Users move assets across the all chains daily. They work with the all the chains. So user move asset across chain every single day. With this, bridges are slow, risky and inconsistent also. Developer waste time to writing a 10 different integration at the same app. So EIL wants to remove that all the complexity by the making Ethereum entire rollup ecosystem work line one network. So EIL wants to remove all complexity by the making Ethereum's entire rollup ecosystem work line one network. Interoperability isn't just convenience; it's a critical infrastructure. Like we can see that what is the Ethereum have to do? The another side chain they have to all the contracts and all the things they have to in the same app they have to put a different contract for different L2 chains. So what EIL solves? Like EIL solution is the EIL hub. They're fast and secure. It's Ethereum connected, layer 2 connected, sidechain connected, app chain connected. They all connected with the EIL. So that is a fast and secure. And if Ethereum to layer 2, layer 2 to sidechain, it's a slow and risky process. So that purpose the EIL is matter in the Ethereum. So now you want to understand what exactly EIL is. So what is EIL? A protocol that lets user perform actions across any L2 using just one signature without switching a chain or manually bridging. Or like in simple words, EIL is the Ethereum native standard for the sending secure verifiable message across any chains. Means think of it EIL as a Ethereum universal cross chain language. You sign a one message and EIL makes your action happen on any chains. Ethereum is a native communication layer, a protocol that lets you perform action on any chain from any other chain and using just one signature. So no manual bridging, no RPC switching, no custom cross chain logic you have to add, or so the EIL gives the standardized message format that works across the L1, L2 and even L3 rollups. Think of it EIL as a Ethereum's universal cross-chain language. You sign a one message and EIL makes you action happen on any chains. So that all works in L1, L2, L3. There's shared security, so standard message format, no custom bridge needed, guess verified, proof verified message. So EIL turns Ethereum into a one big unified network instead of the 50 isolated chain we have to integrate in the Ethereum. So here, what is the user experience? What type of they connected? Here's the end user wallet or user wallet. This is the end user wallet. So single interface. So here's the central hub. This side is the wallet and user is there, and here's the all L2 chains and all the products is there. So central hub is direct access to Arbitrum, Optimism, Polygon, all are they have a direct access. So they connected with the all chains with this layer. So user only interface and talk to with this layer, and they can connect and verified that guess verified, the proof verified, and all the bridges connected with the EIL. So like this type of they working. Then after how that work, like in a simple explanation, forgot all technical stuff for the second. So here's the simplest way to understand the EIL. You sign once. When you sign the transaction once, then your wallet handles all cross-chain steps. Gas handles automatically. Funds arrive instantly in 2 to 3 seconds. No bridges, no RPC switching, and no networks errors. Like here you can see user single this is a single interface interactions. So user can initiate transaction that going to the wallet send via EIL. So here's the EIL hub is there. So that is direct access with all L2s. With this they can do the seamless transfer, and after the confirmation user get their message, not switching here the other networks and other cross chain bridges, and not needed that. So direct EIL direct access to the all L2s chain. So it turns the entire ecosystem into a single seamless experience. So before the understand the what is EIL and how that's solved. So we can see that the before EIL what we do and the after EIL. In this diagram we saw that the user have a multiple interface. Here's the multiple interface, the wallet A, and here's the complex bridge of L2s, and here's the wallet B. There also the complex bridge, the risk and complexity also, and L2B, the another layer 2 that connected with that. Wallet 1 connected with the another bridge, wallet 2 connected with the another bridge, and that risk and complexity to see and identify the amounts. And after EIL, that's make very smoother, like user have a single interface, no multi interface. The super wallet is there, and super wallet direct access to EIL hub, and EIL hub has simple path to L1 L2 all the chains, like layer 2 one chain, layer 2 second chain, Arbitrum, Optimism, like all the chain. They reliable here and all connected to here. So user have to direct access to here and talk with this layer, not needed to go another wallet and see the another chain. So that EIL solve this. Here's the table of before and after, what are the changes happen. So first is user experience. User experience for before EIL, different interface per L2, different chain of L2, then we have two interface also different. Then the consistent UX across all L2s. With this after, application development limited to single L2. In this, we can connect with the multi-chain capable by default. Wallet functionality, basic functionality per chain only the wallet, and super wallet with the enhanced capacity. Cross-chain operations, complex and risky bridges. Like we have to connect with the another bridge to be the cross-chain swaps. So in here, that seamless and reliable transfers. We not need to reliable on the other bridges. Development approach, L2 specific build, and the cross-chain native application. With the EIL, you can make a cross-chain native application also. Institutional adoptions limited by the fragmentation before EIL. After EIL, enabled by the reliability and consistency. So before L2 looks and behave differently. Wallets felt limited, and devs had the rebuild logic for each networks. After EIL, you get a consistent UX, multi-chain apps by default. Wallet becomes super wallet. Bridges become the pointless because we don't need the bridges, and scaling become much better. So this standardization is the real innovations. Now we understand the workflow overview. So now let's talk through the workflow at the high level. What are the workflow? User sign a single Merkle root, and your wallet splits into the multiple user operations. Source chain paymaster locks your fund. XLP provides liquidity on destination chain, like a cross chain liquidity provider. XLP means a cross chain liquidity providers provides gives liquidity instantly on the destination chain. The destination chain runs your call instantly, means execute your calls within seconds. If anything goes wrong, then Ethereum L1 acts as a fallback and verification for the verification and finality. This is the how you can get a fast UX without sacrificing Ethereum grade security. Like user layer, user signs transaction with Merkle root, and wallet layer connected with the wallet splits into the user operations. Source chain is the paymaster that lock the fund, and source chains goes there the provide liquidity and instant execution. And what are the destination chain? All L2 that connect with the XLP layer, the dispute resolution. Then L1 interaction is finality, and for the verification they go on the L1. Of the foundation of EIL and user intents. At the core level of EIL is the concept of intent. And intent is a describe what the user wants, now how to do it. User don't specify the routes and guess logic or chain. They just describe the goal. So here how that understand. If that user don't want to interact and don't know that all the things on logic, so they intend like sign message and describe your goal. I want to send one ether to change one ether to be one USDT. Ether I want to change one ether into USDC. So this is the intent of the user. So they don't know about the guess logic, no routing, no chain switching, and wallet plus EIL handle the all execution. And similar from like ERC-437 user operations, but cross chains. And the actions like a transfer from this to this, and amount of this, the maximum fee is like this. They can get this type of results. So what an EIL message contains? Every EIL message contains like origin chain ID, destination chain ID, nonce, payload in bytes, proof and commitments. They that all thing show like this in the code, like EIL message, the UN256 SRC chain, then destination chain, the payload and the commitment and the proof. This is the cross-chain transaction package. Everything you need to prove that the message is valid and the should be executed. Like sequence diagram, how message the moves, like app doing the message to the origin of EIL then commitment for the Ethereum, and Ethereum verification with the destination of EIL, and then whatever the app that receives the message. How that like sequence workflow is going like this way. This is the full path of cross-chain messages. User sign the transaction and the app creates EIL message. Origin chain, for the origin chain locks the commitments. Proof generator creates the cryptographic proof. L1 is the verifies this proof, and destination chain of verified that message and destination dep execute. So the important part of Ethereum, verify everything, not a bridge, not a third party validator set. Then who participates in EIL? Like the actors in the system are like sender app creates the message, origin chain EIL contract that logs commitments, proof generator builds a cryptographic proof, Ethereum L1 is the verify that proof, destination chain EIL contract that execute the message, receiver app is receives the message. Here's the all every step is standardized. That's the power of EIL. They do by the EIL all the things, sender to be receiver, all things by done in the EIL. The cryptographic backbone of EIL. EIL relies on the cryptography that uses a Merkle proof to verify the message inclusion, uses the state commitment posted on the Ethereum, sometimes supported by the ZK proof depending on chain. Message can't be forged. No one can deny the message history. No middleman can alter the message. So the messages can't be faked. Ensure the sender cannot deny the message later because message in the history. So no one can deny that. That message is inherited Ethereum security guarantee. Here's the Merkle tree, like Merkle tree root, then #1 created and #2. They have a message 1, 2, 3, 4, and that is proof generation like that way. Verify #1, verify #2, and that all are the verify Merkle root. So message will be in the history. No one can alter this. No one can deny from the messages. This is the full workflow of the EIL. Let me simplify the entire workflow. Then app encodes the message. Here the app encodes the message. The first layer, the total is the 7 layer. The first is the app encode the message. Then after message sent to the origin EIL contract. Then after commitment generated. And commitment posted on the Ethereum. After posted the commitment, proof generated, and destination contracts verify that proof and message executed. That's a whole full life cycle of cross-chain operations using EIL. Everything is deterministic and the verifiable. Next is the core concept of EIL stake. So here the main piece is like a wallet. what the in the EIL stack, what are these things do? These are the main component. So the first is the wallet. Wallet creates and signs intents. EIL router and dispatchers that picks the execution path. L2 adapters is connected with the EIL and after going to the rollups. Executor and solvers, that's an optional one, but propose the routes also. Verifiers, the confirm result and using proof. So adapter is especially important in this all component, and any chain that implements the EIL adapter becomes instantly compatible. Then now you have a question like who uses EIL today? So Ethereum L1 is acts like a verification hub for everyone. So multiple L2s means multiple layer 2s are exploring EIL like Arbitrum, Optimism, Base, Scroll, and there are any app chains that are in L2 or another. Any app chains are the following like L2. App chains starting to integrate. And even bridges are starting to redesign themselves around EIL compatibility. The new bridges also know that EIL come, so we have to exploring that bridges and how that bridges to EIL compatibility. So they also starting to redesign. Then the simple like cross-chain NFT move to using EIL, like user owns NFT on L2. Here's the one example that cross-chain NFT move using EIL. Imagine you have an NFT on layer 2 and you want to move it another. Like with EIL, how we can do? The user wants NFT on L2, then sends NFT to another chain. So user signs the once, then message EIL message carries the metadata of that NFT, and destination chain means wrap version. Like that NFT wrap version, destination chain will get. Then fully trust and minimize. So the no custodial bridges, no validator set, fully trust minimize. Like fully trust by the EIL that going to. We are not connected with the different bridges for that NFT to go on the one layer to be another layer. So the small two-chain NFT move illustrations like source chain is the original NFT, one the EIL message, and the carry metadata of the EIL message in cross-chain transfer, and the mint and the wrapped NFT and the destination chain. Whatever that user want to chain from one layer to the another layer, one L2 to another L2, they want to send an NFT, then we can do with the EIL in a simple way. This is the future of NFT mobility. Then we can discuss about like EIL versus old style bridges. What are the difference between the bridges and how that EIL will be the EIL is the good in that. So the first is the feature is security. The most important feature also the security. In bridges, the custom security given by the bridges, and EIL is the Ethereum verified, the security is more. Then message format inconsistent. The every bridges have their own format of the messages, and EIL is the standard format of message. Finality is slow because we have to connect the bridges and they interconnect with them and they all are verified. They're taking a time, and this is a one so unified. Dev effort. It's here's the high. We can like connect different bridges and their message format also different. So we developer take a time to be making a proper bridges. And here's the lower effort. We can easily, this is a standard message format, or we don't have to connect it all the bridges here. So that's a lower dev effort. So bridges rely on like so the bridges rely on the external validators and the custom trust assumptions. That's why all major hacks happens. EIL replaced that the entire model with the pure Ethereum verified cryptography, and this is the fundamentally safer and more consistent. Then next one is why EIL is powerful. EIL brings the shared Ethereum security, removes need for the third-party bridges, standardized message protocols, interop with any chain that opts in, lower dev complexity, means better UX they can get with that EIL we can get a better UX, lower development overheads, compatibility with the other chains, any chains like standard message protocol they have, so no need to third-party bridges and they have a shared security between that. So this is the interoperability layer Ethereum has been missing. So that is EIL brings that. So where EIL still struggles, why that is not introduced and why they are not using everywhere. What is the struggle between the EIL? Of course, it's always with anything or any innovation is always be chance to improvement and something. So of course it's not perfect. Adoption isn't like adoption not universal yet, because all the chains, all the bridges, they're not adopted currently. Ethereum verification is equal to fee overhead. You have to verification by the L1, so that adds fee also. Some chains incompatible. Some chains are incompatible with this EIL. Still evolving standards. This standard is still evolving, not a fully like a universal use currently, but that can be used, because that have a potential to be good, and it's a faster this happen that this this is the early stage of infrastructure. Like ERC20 was in 2017, like that EIL is now. So its adoption like take a time. How EIL ensures trustlessness? Like EIL ensures trustlessness by verified proof on L1, using proof verified on L1, no extra validators, attack surface minimize, replay protections, and nonce based ordering. So if someone tamper with the message, the proof simply fails. So the EIL is a trustlessness. What could go wrong with the EIL? So failures usually comes from weak weak proof system on some L2s, incorrect implementation on app chains, malicious relayers if optional relayers exist, mismatched chain IDs, faulty message passing. These are the engineering risk, not the EL risk. These are not architecture or weakness, but it is an engineering risk. If the any engineer mistaken something like this, then that go wrong for that proof and for the message. So what are the real world use cases of EIL? How and when, where we can use this? So here the real scenario: move funds without bridging. You can want to move or swap funds to the 1 2 second, then it's without bridging. You can do that. Swap on another L2 instantly. Mint NFT on any L2s, like mint NFT elsewhere. You don't want to mint NFT in this L2. You want to another L2, then you can go there also. Then cross L2 gaming ecosystem that need many chain. Cross L2 gaming, because gaming ecosystem that needs many chains. So EIL makes all this smooth, and that all are the real world use cases we can use the EIL. So this all the real world use cases of EIL. Then where EIL is today and where it's going. Currently in as of 2025, it's an active development of EIL. Multiple L2 early implementation is there, moving towards to standardizations and integration in rollups framework, expected to become a ERC for cross-chain communications, likely to become a ERC cross-chain communication for the messaging. We are watching the birth of the major Ethereum primitives. How builders should think about EIL? If you are a builder or developer, how can you think about the EIL? Like always rely on use verified proof, not custom relayers. So always rely on verified proofs. Keep payloads lightweight. Keep your payload small. Handle failure modes. Implement fallback logics. Use message sender mapping properly, and test across chain replay scenarios. Test replay cases carefully. Good cross chain code must be defensive here. Then the high level architecture of EIL. The EIL system sits on the top of ERC 437 account abstractions, multi-chain smart contracts, cross-chain with the paymaster, XLPs means cross-chain liquidity providers, L1 stack managers, and ERC 5792 wallet send calls. So it's built on existing Ethereum, all existing Ethereum standard. It's not a replace them. So here's the how that work, like user layer, the wallet, then direct access to EIL layer, EIL hub, and the smart routing go by the paymaster or XLP layers, and the batch processing, and they go on the different L2 chains and the security check, and then come on to L1 layer. What are the key components inside the EIL? The most important internal components are user, like signs once, wallet constructs Merkle proof operations, paymaster for the handle gas and locking funds, XLP supply liquidity on all L2s, entry point V0.9 execute user operations. This is the where speed meets the security. How that components works in the EIL, like this: the user signs the wallet or in wallet layer, and that goes to entry point. And here's the Merkle proof also happen, and also like connected with the paymaster, so gas and fund given by the paymaster, and connect with the XLP layer. So XLP connected with the different L2s and that execute liquidity and execute their message and liquidity they provide. So this is the work of the all components. Why EIL changes Ethereum forever? With EIL, chains become modular plugins, single security models, opens door to multi-chain apps, composability across ecosystem. This all EIL is the changes how philosophy of how we scale. This all EIL is changes the philosophy of Ethereum how we scale. EIL in short. What is the EIL? Standard cross-chain protocol that is Ethereum verified, that is secure, unified, and developer friendly, because developer don't have to put all bridges and for the different L2 they don't want to go for the different code and replaces fragile bridges. Scale Ethereum and the scale Ethereum ecosystem also. That helps Ethereum scale for the many rollups and the replace the all bridges. So this is the EIL. So EIL is the multi-chain future but simplified version of that. So here's the EIL topic is finished. If you are building in the Ethereum ecosystem, EIL is something you absolutely need to understand because it's going to define the next generation of apps. This is the future of multi-chain Ethereum. Let me know if you want to deep dive developer tutorial.